Okay, so we're going to start with graphing. What you guys have done before is you've graphed in two space. So you've graphed these points, x comma y. And you've had your two different axes, your x-axis and then your y-axis. What we are going to do today is we are going to graph in three space. So we're going to graph the points x, y, z. Here's how those coordinate axes look like. Z is the one that goes up and down. Y goes side to side. And x is what comes out at you. So can you guys picture this? Like y is this way, z is up and down, x comes out at you. Okay. Some different pieces of vocab that you need to know. We have the xy plane. So that's this one right here. We have the yz plane. That's this one right here. And then obviously the xz plane as well. In two space we have quadrants. What do you think we call it in three space? Any ideas? Well, okay, quadrants, there's 4 of them. How many are there here? 8, right? Okay, these are called octants, right? Kind of makes sense. Okay. This I think you've heard before. The z-axis is determined by the right-hand rule. Have you guys done that in physics? No? No? Oh, okay. So right-hand rule you are going to do in physics, I'm fairly certain. Maybe you just haven't gotten to it yet. Those of you in AP, at least. Here's what the right-hand rule says. If you curl your fingers on your right hand from the positive x-axis to the positive y-axis, your thumb is going to point in the direction of the positive z-axis. So if you picture up here, if you put your hand on the y-axis and curl your fingers from x to y-axis, thumb points in the direction of z, which would be up. That make sense? Can you guys picture that? Okay, great. This is going to come up later with vectors, so that's why we need to talk about it now. Okay. So, first example. We are going to graph together the point 2, 3, 4. Okay. So 2 is your x, 3 is your y, 4 is your z. We're going to draw our axes. So there's not graph paper for this, so you're just going to have to do the best that you can drawing the axes. Okay. So what this says, I come out 2 in the x direction. I go over 3 on the y. So I come out 2, I go over 3, and then ultimately I'm going to be going up 4. So down 2, over 3, up 4. Can you guys picture where that is?
Yes.
Okay. It's kind of hard just to plop the point somewhere. So instead, normally what we do is we're going to draw a prism and the point will be one part of the prism. So if I come down or out 2 and over 3, it forms this part of the prism. So this is where I went out 2 and over 3, and then I go up 4. Now that up 4 is part of the prism. Okay, so out 2 over 3, up 4. So maybe right there. And then you're going to fill in the rest. So that's that point 2, 3, 4. Out 2 over 3, up 4. Okay, questions? No. Great. One thing for you guys to know about my style of lecturing, I'm not going to do a whole lot of examples. So we're not going to do 5 examples of graphing points. If you guys struggle with it, we're going to do some more. But for the most part, I'm going to do the examples, and then you guys are going to practice at home, just so that I don't waste any of your time. Sound good? Okay, we are going to do one more of these before we move on, though. Okay, we are going to graph the point -3 to -6. So again, you have your positive x, y, and z. Ultimately, x and z are going to be negative, so we also need the negative portions of those two axes. The negative x will be backwards, and the negative z will be down. Okay, so I'm going to go -3 on x, and then I'm going to go over 2 on y. So I would go -3 over 2, and then down 6. Okay, so again, we're going to be drawing a prism. I like to start with 2 of the planes. So this is the -3 over 2, and then with this one. So the prism should be not horrible to draw, and then you just got to figure out which corner of that, which vertex is your point. So again, we went back -3, we went over 2, and we went down 6. So this is where our point is. Okay. Okay with graphing? Great. We're going to end with graphing also, but we're going to move on now. Next thing that we need to talk about is the distance formula in 3 space. Okay, distance formula in 3 space is almost exactly the same as the distance formula in 2 space. So it's going to be like the Pythagorean theorem, but you're going to have a third element as well. So you're going to subtract your x's, square it, subtract the y's, square it, subtract the z's, and square it. And that should make sense. Okay, what you are going to do is you are going to find the distance between the points in examples 1 and 2. Okay, so take a minute and do that now, please. When you have an answer, check with the person next to you, please. I got the square root of 126.
Yes.
Okay, everybody good? Okay, can we move on? Yes. Okay, next thing we need to talk about is the equation of a sphere. Equation of a sphere is going to be almost exactly the same as the equation of a circle, just three-dimensionally. You're going to have x subtract x naught squared, y subtract y naught squared, z subtract z naught squared equals r squared. And then x naught, y naught, z naught are going to be the center of the circle. When you are ready, you are going to write the equation of the circle with a diameter that has endpoints -1 to 1 and 0 to 3. So take, never mind, we're going to do it together. We don't have time for you guys to do it. Is that okay?
Yeah.
Okay, great. So we need the center, we need the radius. How are we going to find the center? Eventually. Midpoint, right? Midpoint three-dimensionally is the same as the midpoint two-dimensionally. You're going to take the average. So take the average of the x's, average of the y's, average of the z's, and then you end up with a point -1/2, comma 2, comma 2. Radius. Distance formula. A few different options. I can do the distance between these 2 points and divide by 2, or I can do the distance between either one of those points and the center. Are you okay if I tell you what I got?
Yeah.
Okay. Square root of 5/4. So then, if we write our equation, we get x add 1/2 squared plus y minus 2 squared plus z minus 2 squared equals 5/4. Okay. Are we okay with the equation of a sphere?
How'd you get the radius from?
I did distance formula,
Okay.
so either between one of the two endpoints and the center. Okay, good? Okay. One thing that goes along with spheres and circles is the general equation. So for our next example, we are going to find the center and radius of this following sphere. The equation is x squared, add y squared, add z squared, subtract 2x, subtract 4y, add 8z, add 17 equals 0. Okay, do we remember doing this with circles? Okay, what is the process? Completing the square. Okay, I'm going to get all my x's together. So I have x squared, subtract 2x. I'm going to have to complete the square for x. Then we have y squared subtract 4y. We're going to complete the square for y. And then z squared add 8z. Again, completing the square. That's 17. I'm going to move over because I don't need it. Remember, when you complete the square, whatever you add to the left side, you're going to add to the right side as well. Okay, reviewing completing the square. How do I figure out what number goes here? Half and square it. So negative 2 divided by 2 is negative 1. Square that is positive 1. Don't forget to add it to the right side. Again, divide by 2 and square it is going to give us 4. Divide by 2 and square it, well, we should get 16. Okay, if we completed the square correctly, each of these should be perfect square binomials. So when we factor this one, we're going to get x minus 1 squared. Factor that one, you're going to get y minus 2 squared. And then z plus 4 squared. On this side, this negative 17 and positive 17 cancel, and we just get a 4. So ultimately then, our center ends up being 1, 2, negative 4, and we have a radius of 2. Okay. Comfortable with spheres? Questions? This all seems familiar, right? Just adding another dimension. Okay. One thing to know. Quick theorem before we return to graphing. An equation of the form x squared, add y squared, add z squared, add gx, add hy, add iz plus j equals 0. So here g, h, I, and j are all constants. This could represent a sphere, like in the case that we just saw. We completed the square and it was a sphere. It could represent a point, or it could have no graph. Now, what are we going to have to do to figure out if it's a sphere, a point, or it doesn't have a graph? Complete the square. Okay, when would we get a point? What happens when we complete the square? The radius is 0. When would we have no graph? When the square of the radius is negative. Makes sense? So you're going to complete the square. If you end up, like on this example, with a negative number here, that would be an imaginary radius. So that would be a case where you wouldn't have a graph. Okay. Am I going too quickly for us? No? We're good? Okay, great. Let's return to graphs. Next example. We are going to graph y equals 3 in 3 space. So this is one symbol for what you're going to see for 3 space. So this is the real number symbol. The third means 3 space. Okay, here would be my suggestion for you. You are only going to have graphs like this that have 2 variables. So I would start by graphing this in 2 space, what you already know. So you already know how to graph this on an x, y axis. It's going to be a horizontal line. Then I would think about that idea in 3 space. So this here is the xy plane, so that's what we graphed over here. So I would start again by graphing just on the xy plane, ignoring z. So on the xy plane, we talked about this is just a horizontal line. Here it was horizontal. So do you guys see how these two are the same? Okay, what happens now when we introduce z?
The graph becomes a plane.
Yeah, it becomes a plane. So you're going to have to denote that this is a plane. So I'm sorry, that's the best I got for this plane. Can you guys picture that? Okay. In your homework, what you're going to have to do on WebAssign, sometimes it's going to ask you to actually graph it. Sometimes it's going to ask you to describe the graph. So what would the graph look like? So if we were asked to describe the graph, here's what I would say. In 3 space, y equals 3 represents a vertical plane that is parallel. Okay, what plane is it parallel to? XZ. So it's parallel to the XZ plane. And it's 3 units to the right of it. Okay. We got 2 more quick ones I would like to do before you guys go. Can we get to those? Okay. Questions on graphing planes like this? No. Great. Next one. Next one, we are graphing x squared plus z squared equals 1. So like I said, you're pretty much going to be graphing just with 2 variables. If we graph this in R2, our coordinate planes are going to be x and z, or axes are going to be x and z rather. On the xz plane, what would this be? Circle, right? Circle. Okay, so now if we go to R3, graphing on the xz plane again, so ignoring y, something like that. What happens now when we introduce y? What does this become? A cylinder. Yeah, so this circle is going to continue down the y-axis in both directions forever, so it's cylindrical in shape, although it's not going to end. Can you guys picture this? These graphs are incredibly important. So everything that we're going to do this entire semester is incredibly visual. And so you need to be able to picture these graphs to know what you're doing and whether your answer makes sense. Real quick, last one. We're just going to talk. We're not going to write anything down except the equation. Oh, sorry, this is 8. Okay, what's this going to look like? Okay, this is obviously spherical. What happens when we introduce the inequalities? What's this? It's a sphere with the inside filled in, but then we're cutting out the middle. Okay.